Hello, hello students. Today we are going to study error analysis and significant figures. So our today's class is significant figures and error analysis. So, what is significant figure? Our first question is, what is a significant figure? Significant figure in the measured value of a physical quantity till the number of digits in which we have confidence. If the number of significant figures is large, then there is more accuracy in the measurement. So, a significant figures gives us the number of digits of a measured value in which we have confidence. If the number of digits in which we have confidence is less, then the measurement is less accurate. If the number of measurements, number of digits, or better to say, number of significant figures is larger, then accuracy is more. We can actually clear this concept by some example. So I am erasing this one, okay? Examples. Actually, better to say rules. We should write here the rules for finding out the significant figures. Number one, all non-zero digits are significant. Example, 42.3 has how many? Here are all digits non-zero. Okay, so number of significant figures in this example is 3. Okay, so 42.3 has 3 significant figures. .123 has 5 significant figures. So this is rule number 1. All non-zero digits are significant. Please write it down. Rule number 2. A zero becomes significant. A zero becomes significant figure, significant figure, if it appears between two non-zero digits. Example, 5.03 has 3 significant figures. So 5.03 has 3 significant figures because 0 comes in between 5 and 3, which are non-zero. Zero point 4.006 has 4 significant figures. Similarly, etc. etc. So keep in mind that if a zero comes or zeros come in between two non-zero digits, then those zeros are significant. Okay, this is rule number 2. Rule number 3. Leading zeros or the zeros placed to the left of a number are never significant. Example, 0.543 has 3 significant figures. .045 has 2 significant figures. 0.009 has 1 significant figure. Very simple. So leading zeros are non-significant. Leading zeros are non-significant. Here, non-significant figure is 1. Non-significant digits here in this example is 2. In this example, there are 3 non-significant digits. Very simple. Rule number 4. Trading zeros or the zeros placed to the right of a number are significant. For example, .330 has 4 significant figures. $342.900 has 6 significant figures. $392.000 has also 6 significant figures. Keep it in mind. Rule number 5. In exponential term, the numerical portion gives the numerical part gives significant figures. Example, 13.2 into 10 to the power minus 6 has 3 significant figures. So this part is not taken, only this part is taken, and we find the number of significant figures in this part, and this part is called the numerical part, and this is called exponential part. Okay, so 13.2 into 10 to the power minus 6 has 3 significant figures. So we come to the last rule, which is rule number 5, exponential term. So there are 5 rules by which we can find out the number of significant figures in a particular value. Our next part is rounding off. Rounding off a number. So how can we round off a number? For example, there are several rules. I'm writing those rules. Please note it down. If the digit to be dropped is less than 5, then the preceding digit is left unchanged. For example, y equals to 3.72 is rounded off to 7 point, rounded off to 3.7. So y equals to 3.72. When we just round off up to 1 decimal place, then we drop this 2. So 2 is less than 5. That is why after rounding off, the result comes 3.7. Rule number 2. If the digit to be dropped is more than 5, then the preceding digit is raised by 1. For example, .977. When rounded off, 3.87. When rounded off to 1 decimal place, then it gives 3.9, because we are dropping the digit 7. 7 is more than 5, so preceding digit, that is 8, is raised by 1, that is 3.9. Rule number 3. If the digit to be dropped is 5, earlier we have seen that the digit to be dropped less than 5, more than 5, and here it comes the digit 5. If the digit to be dropped is 5, then what happens? Then there are several condition comes. We are just seeing these. If the digit to be dropped is 5, then the digit followed by digits if the digit to be dropped is 5 followed by digit other than 0, then the preceding digit is raised by 1. For example, 7.352 when rounded out gives up to 1 decimal place gives 7.4, because 5 is dropped, the following digit is 2 which is non-zero, then the preceding digit, that is 4, is raised by 1 and it becomes 7.4. So here comes a question in our mind: what happens if the digit is 0, right? So our next rule is if digit to be dropped is 5 or 5 followed by digits followed by zeros, then preceding digit is left unchanged if it is even. So preceding digit is even, then it is left unchanged. For example, y equals to 5.450, when rounded off it gives 5.4, because 5 is dropped. After that 0 comes and the preceding digit is even, so even digit is left unchanged, so it becomes 5.4. So here comes another question: what happens if the preceding digit is odd? So we write our next rule: if digit to be dropped is 5 or 5 followed by 5 followed by zeros, then preceding digit is raised by 1 if it is odd. So we can write this example: y equals to 5.350, when rounded off up to 1 decimal place, then it becomes 5.4, because 5 is dropped, 0 comes after, and the digit comes before is odd. We know that when the digit before 5 is odd, then it is raised by 1, so it must be 5.4. So when we round off 5.350 up to 1 decimal place, it becomes 5.4. Please note it down. Now we see we are going to find out the number of significant figures in our calculation. How can we find the significant figures, number of significant figures in our calculation? There are two different rules. Rule number one, if we just do addition or subtraction, then we have to see minimum number of decimal places given in the numbers. Here is the example. We have taken 44.4, 7.22, 0.567, and we are adding all these numbers. So 44.4 has only one decimal place. So after addition we get 52.187. So answer should have been given in one decimal place. So our answer should be 52.2. Why 2? Because we have studied in our previous article that when the digit to be dropped is more than 5, then the previous digit is raised by 1. Here the digit 8 is dropped, so the previous digit is raised by 1. So answer becomes 52.2. Here comes the rule number 2. Our previous rule was about addition or subtraction. The rule number 2 is about multiplication and division. So in case of multiplication and division, we should notice the number of significant figures, not the least decimal places, as we have learned in our previous rule in case of addition or subtraction. Here we find the least number of significant figures in the multiplication or division. In this example, 172.02 multiplied by 0.43 gives 73.9686. In this multiplication, 172.02 between 172.02 and 0.43, we see that 0.43 has minimum significant figures, and that is 2 significant figures. So our answer should have been in 2 significant figures. So 73.9686 when rounded off to 2 significant figures, then it gives 74. This rule, same rule is applicable for division. Keep it in mind. The rule is different for addition and subtraction, and when it comes multiplication and division, the rule becomes different, and in this case we see the significant figures, not the decimal places. So our next part is order of magnitude. We know that in our scientific notation, any number is represented by p into 10 to the power of y, where p is called numerical value and y is called the exponent value. So p into 10 to the power of y is the scientific notation or scientific form of a number or any value we get as answer, or in any experimental value, or in any experiment we find something and write in this form, then p is called numerical value and y is called exponent value. If the numerical value is less than 5, then order of magnitude is 10 to the power y. So if p is less than 5, then order of magnitude is 10 to the power y, no problem. So what is order of magnitude? Actually, order of magnitude gives us about the idea how big or small the thing is. Okay. So p is not a very significant thing here. Okay. So in case of order of magnitude, the numerical value is not a very significant thing. It actually helps us to find out the order of magnitude. If the numerical value, that is p, is less than 5, then order of magnitude remains the same, and if the p is greater than 5, then in order of magnitude we raise the term or power by 1. So ultimately, if p is or numerical value is greater than 5, then it becomes the order of magnitude becomes 10 to the power y plus 1. We give an example. 2.8 into 10 to the power 8 meter per second has order of magnitude 10 to the power 8 meter per second. Why? Because 2.8 is less than 5. So order of magnitude remains unchanged, 10 to the power 8 meter per second. But in the next example, we see that 6 into 10 to kg has order of magnitude 10 to the power 4. So why this thing is happening here? Because 6 is greater than 5. So order of magnitude is raised by 1. So 10 to the power 3 becomes 10 to the power 4. So order of magnitude is 10 to the power 4 kg. So this is all for today. In our next class, we will learn about, this is our first part of this class. In the second part of this class, we will learn about error analysis. Okay. If you like this video, please subscribe to my channel and give lots of like. Thank you.